Hello everyone, welcome to Unacademy, India's largest online learning platform where thousands of students like you are getting benefited out of it. Just checking whether this is going live or not. Okay, now, yes, I am now live on. Okay, so, so welcome to today's class on GATE 2021 paper discussion of analog electronics by of the branch Electronics and Communication Engineering. In the previous two classes, we discussed about the analog electronics part of two other branches, instrumentation engineering and then electrical engineering we have discussed. Today, we will be discussing about Today we will be discussing about the questions of analog electronics of ECE, that is Electronics and Communication Engineering. We'll discuss. Okay. So myself, Shravan Kumar. I have a master's degree from JNTUH in Wireless System Design. I have a 10 plus years of teaching experience and I can handle subjects like EDC, analog electronics, digital electronics and EMFT. I have a special code for all you guys that is called SVS10, which will give you 10% discount on Unacademy Plus subscription. Unacademy Plus subscription. So what is Unacademy Plus subscription is, the benefits of Plus subscription is going to be, you'll be having live classes, you listen to all the live classes, you can have a crash courses, you will be having a weekly test. So this is very important for any GATE aspirant. Writing weekly test is very important. Writing weekly test is very important. And apply doubt. You will be given every 4th hour is going to be a doubt solving session, and the sessions will be in English and Hindi. Sessions will be in English and Hindi. And you have something called rank improvement batch. You have something called rank improvement batch, right? So that rank improvement batch is like if you are getting some low rank in the previous GATE examinations, and if you want to increase your rank, this will help you a lot. This will help you a lot. Okay. And we have something called iconic subscription. Along with the benefits of the Plus subscription, we are going to have something called a personal coach. You'll be having. You'll be having a study planner. You'll be having a study booster sessions, and then a personalized test analysis will be done. Personal test analysis will be done, and then a preparatory study material will be available for you guys. That is specialized notes and practice sets will be available. This is all about your Plus subscription and iconic subscription. If you look at the fee structure, for 12 months, it is going to be 27,225 rupees after using this code of SVS10. That is 10% discount when you use it. For 18 months, it is going to be 34,650 rupees. For 24 months, it is going to be 39,600 rupees. This is all about a Plus subscription. So if you want to go for a iconic subscription, for 12 months, it is going to be 45,225 rupees. For 24 months, it is going to be 66,600 rupees. Okay, so this is after using 10% discount. Sir, as I told you, so this 10% discount is going to become 5% very soon. So I would request all you guys, please join us as early as possible to get this 10% discount. After that, we will be getting only 5%, sir. Right? So use this opportunity as early as possible. Okay. How will you get this is simply download Unacademy app, install it. After you install that, you'll be asked to select your goal. It should be GATE and ESE, and then click on Plus subscription. Once you click on the Plus subscription, you'll be given Get subscription. Okay, click on Get subscription, and it will be for 12 months and 24 months. So use this code SVS10. Use this code SVS10 to get 10% discount on it. After that, you'll be asked to click on the proceed payment. Once you click on the proceed payment, you'll be taken to different type of payment methods like debit card, credit card, EMI, UPI, wallets, net banking. This is how we will be generally doing this. So we have started something called targeting ESE Engineering Science Examination for 2021. So we have started a new batch we will be starting a new batch on 18th of this February. 18th of the February. They are the top faculty members for us and use the code. Use the code SVS10. Use the code SVS10 to get 10% discount on it. You will get 10% discount on it. Okay. Yeah. So very important, sir. This is the top faculty members. Yeah. This you are going to have a new batch. And I would request all of you to follow me on Unacademy at this. Right? Okay. Now we'll start discussing about question number 1. The question number 1, and sir, this is all memory based. As I told you, this is all simply memory based. A memory based. These are all memory based questions, sir. Right? This is all memory based questions. So, and asymmetrical periodic pulse train and asymmetrical periodic pulse train, V in is equal to 10 volts applied with T on is equal to 1 millisecond, and off time, T off is going to be 1 microsecond. So this is 1 millisecond, this is 1 microsecond, which there's a lot of difference. There's a lot of difference between these two values. T on is very, very high when compared with T off. Okay. Is applied to the figure shown below. Find here actually what he was asking is assume that ideal diode. So here actually as I told you, this is memory based. So what he was actually asking is V naught maximum minus V naught minimum. He was asking actually, right? So he asked us to write what is V naught maximum minus V naught minimum. V naught maximum minus V naught minimum is what he's asking, right? Look at this. We have a 0 to 10 volts as a train. It's a pulse train. Maximum value is going to be 10 volts. Maximum value is going to be 10 volts and minimum value is going to be 0. And we have a capacitor of 20 nanofarads and a resistor of 500 kilo ohms and a diode. Sir, whenever you see a capacitor here, so what you should know, sir, capacitor and diode combination is nothing but a clamper circuit. Okay, you should be very much careful about this. It is a clamper circuit. Now, first of all, let me try to draw. What is input waveform. What is the input waveform, so that I can. What is the input waveform? If you look at the input waveform, so it is having a pulse train whose on time is very high when compared with the off time. Off time is very, very less. So I assume that this is going to be what I'll use some other pen so that we will be having some clarity. Okay, this is going to be, let's say, some T. So this is a T on. This is going to be T on. So which is how much, sir? This is going to be 1 millisecond time, and here it is going to be a small portion, and I could say this is going to be T off, which is going to be 1 microsecond, and the lowest value is going to be 0 volts and the peak value is going to be 10 volts. So here is what V input. This is what the input he has given. This is what input and he has given. Now we'll see what happens when V input is equal to 10 volts. Now if you go back and see, when V input is going to be 10 volts, when V input is going to be 10 volts, assume that the as the capacitor is short circuited, because it acts like a short circuit for sudden changes of the voltages. So now what happens to diode? Now here, look at the important thing is we should know what will happen to the diode. So the diode will be forward biased, because the positive terminal of the battery, the positive terminal, I mean to say, anode of the battery is, sorry, anode of the anode of the diode is connected to the positive terminal of the battery, and negative terminal of the battery is connected to the cathode. So now what happens to diode, sir? Diode will be forward biased. So can I say, so when Vin is equal to 0, diode is forward biased. Forward biased. Whenever the diode is the forward biased, so how the circuit looks like, sir? If you look at here, so we have a resistor here, and then this diode is a short circuited, and you have a peak value of, assume that is going to be 10 volts. This is what you are applying. So now you can see here, though we have some resistor here, but in parallel we have a short circuit. So the current will start flowing. In this loop. So what is the use of this? There is no use of the resistor because we have a short circuit in parallel. Always current chooses the low resistive path. Chooses the low resistive path. Now what happens with the capacitor here? Importantly, now the capacitor starts charging. Capacitor starts charging. Now when the capacitor starts charging, and it will reaches, so in 1 millisecond time, so the capacitor reaches to a maximum value of the input. So the capacitor voltage across the capacitor now becomes voltage across the capacitor voltage across the capacitor Vc is going to be the maximum value of this. So how much is that? That is going to be 10 volts. The capacitor voltage is going to be 10 volts now. Capacitor voltage is going to be 10 volts. Now in the next case, when V input is 0, when Vin is equal to 0. Now when Vin is equal to 0, now see what will happen, sir. When V input is equal to 0 means what happens to diode then? Diode will be reverse biased, yes or no? Diode will be reverse biased. Diode is reverse biased. Diode is reverse biased. When the diode is reverse biased, now what happens, sir? Simply here you have a capacitor. This diode is open circuited. But now the capacitor comes into picture. Sorry, the resistor comes into picture. So here you have a 0 volts here. So now the capacitor. Now what happens, sir? Capacitor acts as a voltage source. Now the capacitor acts as a voltage source. Now the capacitor acts as a voltage source. Capacitor acts as a voltage source. Now, and it discharges through the resistor R. Assume that this is some resistor. Discharges through the resistor R. Right? So now we need to find out at what speed this resistor discharges. That is called time constant. Time constant tau is going to be R into C. R into C means how much is R, sir? I think it has given as a 500 kilo ohms, that is 10 to the power of 3. And how much is the capacitor? Capacitor is, I think, as per my knowledge, is going to be 20 nanofarads. It's going to be 20 nano, means 20 into 10 to the power of minus 9. If you look at here, what you are going to get is going to be, this is going to be 10 to the power of 3, 4, 5, 6, 7. So 10 to the power of 7 into 10 to the power of minus 9, I can say 10 to the power of minus 2. The tau is going to be 10 milliseconds. The discharge time is going to be tau. The time constant is going to be 10 to the power of 10 milliseconds. But what is a T off? T off was very less. T off is very less. That is 1 microseconds. 1 microsecond. So the time constant tau is far greater than T off. Whenever time constant tau is far greater than T off, whenever the time constant tau is far greater than T off, then the voltage, the capacitor discharge voltage is not considerable. It means that is VC maintains a constant voltage of 10 volts. 10 volts. Now apply KCL. Now apply KVL. If you after applying KVL, apply KVL now. Apply KVL to find out what is output. So if you apply KVL, simply I can write V in minus VC minus V out is going to be 0. That is V out is going to be V in minus VC. So we know that VC is the voltage across the capacitor, which is going to be minus 10 volts, is going to be V output, right? To get what is V output maximum, what you have to do, sir? You have to substitute, is going to be V in maximum. V in maximum minus 10. So how much is the V in maximum? V in maximum is, if you go back and see, V in maximum is 10. V in maximum is going to be 10 minus 10. So 10 minus 10 is going to be 0. So V output maximum is going to be 0. V output maximum is going to be 0. Now what is V out minimum? V out minimum. V out minimum is going to be V in minimum minus 10. So what is V in minimum? V in minimum is 0 minus 10. So V out minimum is going to be minus 10 volts. So V out minimum is going to be minus 10 volts. But what he was asking, sir, is asking actually V out maximum minus V out minimum is asking. So what is the V out maximum? We got 0 minus what is V out minimum? We got minus 10. So how much you are going to get is going to be 10 volts. So V out maximum minus V out minimum is going to be 10 volts. V out maximum minus V out minimum is going to be 10 volts is the answer. So if you try to draw, waveform, output waveform. If you look at the output waveform, it will be like this. So this is going to be what? This is going to be 0 and this is going to be minus 10. This is going to be minus 10. So, sir, actually, frankly speaking, this much analysis is not required, sir. This much analysis is not required. See this, I have explained all this concept for the students who are preparing, who are in second year and third year and or final year, who are preparing for GATE 2022 and 2023. If you are already prepared for GATE 2021, so very simply you can answer this question, sir. So whenever you see the circuit, you can see that this is a clamper circuit. This is a clamper circuit. For a clamper circuit, the peak to peak value will not be changed. Very simple. The peak to peak value will not be changed. Yes or no? V output maximum, V input must be equal to the what is there in the V input. That is, the peak to peak value of the input must be same as that of V output peak to peak. So actually, in the examination, you can answer this question in 10 seconds, frankly speaking. After reading the question, you can answer the question in 10 seconds. Simple, because this is a straight away, this is going to be a clipper circuit, or hardly 30 seconds. After, even if you read the question and write the answer, so it will take only 5 to 30 maximum of 35 seconds it is required. Okay, not even 1 minute is required to answer this question, right? You need not put any pen on the paper. Directly you can answer this question. Okay, so very easy question this is. Very easy question. Okay, next. Here comes question number 2, which is on MOSFET. So one question was asked on diode. One question was asked on the MOSFET. Two or three questions were asked. I think next question is also on the MOSFET. No, 3 questions were asked based on MOSFET, sir. So actually, unfortunately, there is no question based on BJT. So the BJT is completely missing in analog electronics circuits, electronics and communication engineering question paper. So this totally the shift is moving towards the MOSFET. So the GATE aspirants 2022, GATE aspirant 2022. Remember that. More focus is on MOSFET. So if you're aspiring 2020 to 2023, so learn MOSFET very concentrate MOSFET heavily, right? So what is asking now? MOSFET circuit is shown below. GM1 and GM2 are respective transconductors, and then conductances. This is not conductances. And R0 and R02 be the output resistances of M1 and M2 respectively. Very good. The voltage gain of the circuit is asking for voltage gain. It is V output by V input is asking. V output by V input. So whenever he is asking V output by V input, immediately you should know that. You should use a small signal analysis. Small signal analysis required. Right? Small signal equivalent circuits. Small signal equivalent circuits you should use, right? So now we try to use that small signal equivalent. So assume that this is going to be, anyway, this is going to be gate, this is going to be source, this is going to be drain, and this is going to be source, this is going to be gate, and this is going to be drain. So this is for AC analysis, DC voltages must be grounded. So if you look at actually what happens is these two M1 and M2 will become parallel if you want to measure V output and V input. Okay, these two M1 and M2 will be parallel. Even actually this M1 is acting like a load, frankly speaking, because this gate is grounded. Anyway, I come back to that part at the end, but still first what I try to do, sir, I try to do small signal equivalent model, small signal equivalent model, right? Okay. So this is going to be actually an R equivalent. If you want me to tell directly, I'll take and tell. This is also a very equivalent R equivalent. R equivalent nothing but you can one by GM into in parallel with R naught one. 1 by GM into 1 by GM1 into R naught 1 is going to be what you are going to get. And then so this is going to be M2 is going to be R naught 2 will be there. So 1 by G1, 1 by GM1 in parallel with R01, in parallel with R02 you are going to get. And then so actually the approximately the answer is going to be C. Approximately the answer is going to be C. Okay. Approximately the answer is going to be C. Approximately the answer is going to be C. But we'll try to go with the flow. I'll try to explain the entire answer and then I'll come back to this at the final, at the end. Okay, now we'll see. First, let's try to do a small signal equivalent model. So if you look at the small signal equivalent model, very important, sir. The small signal. First, let us try to connect for G1. So this is G1 is grounded already. So here I have a plus and then minus. Can I call this as a VGS1? VGS1, and then this is going to be a source. And I have a equivalent circuit here. What is this, sir? What is this? Current source. Current source GM1 into VGS1. And again, in parallel, sir, when he mentioned the resistance, you should definitely consider the resistance, which is R0, R01, R01. That is going to be drain. If you look at the drain of the M1, it is actually grounded. It is actually grounded. Okay. But the source is connected to V output. The source is connected to V output. Actually, this is also grounded. If you look at here, this drain is connected, but here you have this is connected to V output. This is connected to V output. This is connected to V output. Now we will try to draw the equivalent circuit of the M2. If you look at the equivalent circuit of the M2, this is going to be G2. This is going to be G2. Here you have a V in actually. Here you have V in plus and then minus. This is going to be VGS2, and I'm going to have as current source of GM2 into VGS2 in parallel with the resistance, which is resistance. Which resistance, sir? Which resistance? It's going to be R02, R02, and this source, and this is also source. This is the drain. So if you look at this source of the the source, obviously I told this is going to be grounded. So obviously this is going to be grounded here. This is going to be grounded here. But what happens to diode drain? What happens to drain? This is also connected to V output. V output. Yes or no? Because the drain of the M2 transistor is connected to V output. So can I call this as a V output? V output. So now I am trying to connect both of them here. If I connect both of them, now what will happen here is, if you look at here, this V output must be. Now I'll try to draw the equivalent circuit. Now what will happen, sir? This portion and this portion will be in parallel. This portion and this portion will be in parallel. So shall I draw it? So anyway, this VGS1, I'm trying to put it on the other side. Now you'll see, I try to draw the equivalent model. Sir, if you are able to draw this equivalent model, you are done with the output, sir. Charan, I'll update it in couple of days. I'll update in a couple of days, Charan. Sure, I'm going to restart the EDC, Analog Electronics and EDC. Both of them I'm going to handle. I'll update it. I'll update it. Don't worry. Keep following this channel. So definitely. So are you preparing for GATE 2022 or ESE 2021? I'll write this is going to be G2 plus minus VGS2 K22. So don't worry, yaar. We'll have a full course. You can attend all subjects. You can attend full course with a lot of enthusiasm. We'll try to finish two subjects, if possible, three subjects. Right? Just follow me. Just follow me. Just follow me. Okay. So here, this is going to be GM2 into VGS2 in parallel. In parallel, you are going to have resistor R01, and this is anyway, this is grounded. This is grounded. So if you look at here, this D is grounded and GM1 and VG1 is going to be in the opposite direction. So I'll do one thing. I'll draw this with green. So here is what you are. Here it is going to be GM1 into VGS1. In parallel, you will be having a resistor R02. R02. Okay, R02. R02. Anyway, this is one more interesting thing here. One more interesting thing here you can see. Sir, if you look at here, this VGS1, the source to ground, V output is also directly connected from source to ground. Source to ground you need to calculate, yes or no? This V output is nothing but the voltage drop across from this terminal from source to ground. Can I call this VGS1 is going to be minus V out? Minus V out. So VGS1 is going to be minus V out. So this GM into VGS1 can be written as GM1, So GM1 into minus of V output. So I'll write this going to be minus GM1 into V output. So now I will change the direction of this. I'll change the direction of this. So here you are going to get output here, V output. So can I write this is going to be V out. So if it is going to be V output, then the equivalent will be, if you change the direction now, so if this is going to be V output, then so you'll get GM1 into V output here. GM1 into V output here. So this is equal to what, sir? It is not equal to the resistance output, same voltage you are getting, and you are having only one resistance, one value, GM1. So it is equal to 1 by GM resistance, GM1. This is equal to a resistance 1 by GM1. Now what you will get here? R01 in parallel with 1 by GM1 in parallel with R02. Okay. Now this VGS2 is nothing but the voltage across this V output. Okay. Now what is this GM into VGS2? VGS2 is nothing but V in. right? Now what I'll write here is V output is equal to, so V out is equal to, if you look at here, GM2 into VGS2, GM2 into VGS2 multiplied by, so 1 by GM1 in parallel with R01 in parallel with R02. So what is this VGS2? VGS2 is same as that of V in or not? So I can substitute as VGS2 is equal to V in. So V output is equal to V in into GM2 into R01 in parallel with R02 in parallel with 1 by GM1. So I'll write is going to be V out by V in is equal to GM2 into R01 in parallel with R02 in parallel with 1 by GM1. So this is the answer. This is the answer which you got. This is the answer you'll get. Very easy, sir. Very easy. Only thing is you should know first thing is you should know the small signal model, sir. Small signal model. Sir, I'll tell you one shortcut here. One shortcut here is. So what is that shortcut is method 2. So method 2 I'll tell you here. In method 2 directly I'll tell method 2. So consider M1 transistor. So if you look at the M1 transistor, here you have V output and you have the transistor like this, which is grounded. This is a drain, this is a source, this is a gate, and this gate is also grounded. This gate is also grounded. It means this gate which is grounded like this. This is grounded like this, drain, source, and then this is going to be some gate which is almost equal to a resistance. Yes or no? A resistance. I can call this resistance as R equivalent. R equivalent resistance. R equivalent resistance. So this R equivalent resistance is nothing but whenever this is equivalent. So this is going to be M1 anyway. We can say M1. So here I am saying M1. Anyway, it's going to be M1. So this will be equal. This R equivalent is always equal to, remember. So if R0 is not there, if R0 is not considered, then it is going to be simply 1 by GM1. But he asks us to calculate R01 also, consider R01 also. So this is going to be the R equivalent circuit. Now this R equivalent is in parallel with the resistance of R02. So obviously immediately what you should get, sir, this is 1 by GM1 in parallel with R01 in parallel with R02 should be the answer. Immediately your answer will be this. So then it will be multiplied by GM2. GM2 into 1 by GM1 into in parallel with R01 in parallel with R02. Okay. GM2 into 1 by GM1 in parallel with R01 in parallel with R02 is what you are supposed to get. Okay. So the answer is directly option C was the right answer. Option C is the right answer. Sir, options may change depending on the IIT Bombay's. This one. So options may change. So you guys need not worry. Okay. Next here comes the problem number 3. I think this is problem number 3. Ideal op amp amplifier V reference is fixed. Okay, V reference is fixed. V out is going to be 1 volt for V in is going to be 0.1 volt. V out is going to be 6 volts for V input is going to be 1 volt. Here this is also volt. This is comma. Where V output is measured across the load resistance RL. Okay, this is RL. V output connected at the output of an operational amplifier. The value of RF by Rin is asking us to calculate the value of RF by Rin. RF is this RF by Rin is asking. No problem, sir. No problem. No problem. Assume that this is going to be some A and this is going to be some B. Here I am going to have some voltage VA and this is going to be VB, or you can also cap V plus and V minus, whatever you want to assume, you can assume VA plus VB. Just a second. Yeah, I'm just changing the settings of my view. Yeah. Okay. Now we'll try to solve this problem. Now we'll try to solve this problem. First of all, apply KCL at node A. 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 If I apply KCL at node A, what you are going to get is VA minus VRF by R1, VA minus VRF, V reference by R1 plus VA minus 0 by R2, VA minus 0 by R2 is going to be 0. Right? So I can write VA by 1 by R1 plus 1 by R2 minus V reference by R1 is going to be 0. I can write this is going to be VA into R2 plus R1 by R1 R2 is equal to V reference by R1. So this R1 and this R1 will get cancelled. This R1 will get cancelled. So what I required, sir, actually I required originally I required what, sir? I required the value of VA. So VA is going to be V reference into R2 by R1 plus R2. Even if you had applied a voltage divider rule, you would have got the same value, right? The voltage divider rule. If you apply voltage divider rule across the load resistance R2, you'll get same thing. VA is equal to V reference into R2 by R1 plus R2. Both of them are same. Yes or no? Now apply KCL at node B. Apply KCL at node B. Apply KCL at node B. If you apply KCL at node B, VB minus V in, yes or no? VB minus V in by Rin, plus VB minus V output by RF. V out by RF is equal to 0. So can I write this as VB into 1 by R in plus 1 by R. I am writing directly, sir. RF minus V in by R in minus V naught by RF is equal to 0. So if you want me to write it, I can write this as VB into R in plus RF by R in RF minus V in by R in is equal to V naught by RF. Sir, I just wanted to write directly only I'll write a V naught. So V naught is going to be what, sir? So VB into RF by R in plus R in RF by RF into R in minus RF by R in into V in. So this RF and this RF will get cancelled. So V output is going to be VB into R in by R in 1 plus RF by R in minus RF by R in into V in. Sir, from virtual ground concept, from virtual ground concept, from virtual ground concept, V plus must be equal to V minus, that is VA must be equal to VB. So VB is now what I can write is going to be VA is equal to V reference into R2 by R1 plus R2. If I substitute it here, so V output is going to be V reference into R2 by R1 plus R2 into 1 plus RF by R in minus RF by R in into V in. Now we got some formula. V output is going to be V reference into R2 by R1 plus R2 into 1 plus RF by R1 plus. So what is the given clue, sir? The given clue is here is V output is going to be 1 volt when V input is going to be 0.1 volt. V output is going to be 6 volts when V output. So when V input changes, V output changes. So here when V input is changing, V output is changing. But what about this value, sir? Is this value changing? Do we have any substitution of V in and V output here? No. So now for that case, what I am trying to do, sir, assume this entire term as X. So if we assume that the entire term is going to be X, is going to be V output X minus RF by R in into V in. Right? Now I try to first case for V in is equal to 0.1. So V output is going to be 1. That's what he has given, right? Yes or no? 0.1, 1. So if you substitute here, 1 is equal to X minus RF by R in into 0.1. So assume this is going to be equation number 1. For V in is equal to 1 volt. So V output is going to be 6 volts. If you go back and see, so for V in is equal to 1 volt, V output is going to be 6 volts. V in is equal to 1 volt, for V output is going to be 6 volts. So 6 is equal to X minus RF by R in into 1, equation number 2. So anyway, we are not much bothered about these two X values. So do 2 minus 1. If you do 2 minus 1, you're going to get 6 minus 1. X minus X is one term. Then 2 is going to be minus RF by R in minus of minus plus RF by R in into 0.1. 0.1. So this is going to be 5 is equal to anyway X minus X is going to be there. So if you take RF by R in is common. If you take RF by R in common, so IRAR. This is going to be 0.1 minus 1. So I'm going to get RF by R in as a minus 0.9. It's going to be 5. So RF by R in is what is asking. This is going to be 5 by minus 0.9. I think you'll get this will be minus of 5.555 is going to get this. So anyway, this he may be asked mod of, if it's going to be mod of, so then it is going to be RF by, generally resistance should not be negative, right? So you'll get 5.555 is the answer. What is the option number, sir? Option number D is here. From the given problem, option number D is going to be the answer. Option number D is going to be the answer. So option D. Option D is going to be the answer. Okay. Okay. Option D is going to be the answer. We'll see this another problem. Problem number 4. A circuit with an ideal op amp is shown in the figure. A pulse V in of 20 milliseconds. Direction is applied to the input. Okay. The capacitance is initially uncharged. Okay, the capacitance uncharged means voltage across 0 minus is going to be 0. Voltage across the capacitor for 0 minus is going to be 0. Okay. The output voltage V output of this circuit at a t is equal to 0 plus. Okay. So at t is equal to 0, input is changed from 0 to 5 volts. Now he's asking what will happen to the V output whenever this is going to be there. Sir, first of all, these two capacitors are in parallel, means, so what we'll get, sir, when parallel they are, simply you'll get one capacitor. There is going to be 2 microfarads capacitor you're going to get. So if you simplify and redraw the waveform for convenience. So you're going to have a capacitor here. Minus and then plus. This is grounded, and you have a resistor here. This is, I think, 10 kilo ohms, and you are going to have 2 microfarads, and you have a 5 volts. I think 5 volts is given, right? Yeah, peak voltage of 5 volts, or whatever train. Anyway, you have a train kind of thing, in the V output. Sir, he is not asking us to calculate V output at the end of the pulse. He is simply asking us to calculate at the immediately after 0. So if you look at immediately after 0, if you look at immediately after 0, that is asking for 0 plus. 0 plus. So one thing we should remember here is, point is the voltage across node. This is very important. If you note, sir, this is like, combination of your network theory and then analog electronics. This is a combination of network theory and analog electronics. You should know the small information about the network theory. You should know the small information about network theory, how this capacitor behaves, right? We know that the voltage across the capacitor, cannot change instantaneously. That is, voltage across the capacitor for t is equal to 0 plus, will remain same as that of unchanged value 0. As is told, it is suffering with this cold, yeah. Lot of cold. I don't know. Okay. So now what happens is the capacitor acts as a short circuit. Capacitor acts as short circuit. Short circuit. So now can you say directly here this will be short circuited. Short circuited. This is grounded. This is minus. This is plus. And then here you are going to have the resistor of 10K, and this is going to be 5 volts. Sir, if this is the 5 volts, now is asking us to calculate the V output. V output. Sir, if this is the 5 volts, obviously at this point also I'm going to have 5 volts only. 5 volts only. So, so, so now what is V plus, sir? V plus is going to be 0 and V minus is going to be 5 volts. V minus is going to be 5 volts. Here, V minus is greater than V plus. V minus is greater than V plus. So, whenever V minus is greater than V plus, V plus, obviously the V output is going to be minus V sat. V output is going to be minus V sat, irrespective of the feedback. Actually, there is no feedback at all. No feedback at all. There is no application of this feedback. No use of giving this feedback. So V output is going to be minus V sat. So what is minus V sat? So according to this is going to be the value. Positive feedback. If this is going to be less than 0. If this is less than 0, you are going to get plus V sat. As non-inverting terminal voltage is higher than the inverting terminal voltage is higher than non-inverting terminal. Obviously, the V output is going to be minus V sat. V output is going to be minus. So your V output is going to be, I'll directly write here, V output is going to be minus V sat. So which is equal to V output is going to be minus 12 volts. This is easy problem. But when you look at this problem, you feel that this is some complicated problem. Frankly speaking, this problem is easy problem, sir. Frankly speaking, this problem is easy problem. Okay. Okay. We'll see the next problem. Yeah, this is problem number 5. Only 5 problems were asked. Sixth problem is another problem was asked in MOSFET, but I'll try to push that problem into EDC. Tomorrow I'm going to discuss that. Why I'm saying, sir, there you need not apply any small signal model. So it's just related to the biasing problem. That is the reason why that MOSFET problem I will discuss in case of EDC, which I will discuss tomorrow. Tomorrow I am going to discuss EDC problem. Okay. Now we'll come back and see here. Consider the circuit with an ideal op amp. Ideal op amp shown in figure. Assuming V input is far less than VCC. Okay. This is VCC. This is the VCC. Okay. V reference is also far less than VCC. No problem. The condition at which V output is equal to 0. Oh, Acha is asking what condition V output is going to be 0. Okay, very simple, sir. Very simple. Directly we can do it very easily. So anyway, this voltage is going to be 0 volts because it is directly grounded. According to virtual ground concept, this is also 0. This is also 0. But for convenience, assume that is going to be some X point. Right? Apply KVL at X. Apply KVL. Not KVL. Why you need KVL? You should apply KCL. KCL at node X. Okay. So it's going to be Vx minus V in by R. Vx minus V in by R plus Vx minus Sir, you can see here this is going to be minus and plus. It's going to be minus and plus, not plus minus. So be careful now. It's going to be minus plus. So obviously it's going to be Vx minus of minus V reference by R plus Vx minus. So Vx minus V output. V output by R. V output by RF is equal to 0. So I can write this as going to be Vx minus V in by R plus Vx plus V reference by R plus Vx minus V naught by Rf is equal to 0. So according to virtual ground concept, V minus is equal to V plus is equal to Vx is equal to 0. So if you substitute all this Vx is equal to 0, now what you'll get here is going to be 0 minus V in by R plus V reference by R minus V naught by Rf is equal to 0. Okay, so V naught by Rf is equal to, can I take V 1 by R common? I'll take 1 by R common. This is going to be V reference minus V in. So V naught is equal to Rf by R into V reference minus V in. So V naught is what we got is going to be, V naught is going to be Rf by R into V reference minus V input. But what he says, sir, he is saying, given condition is asking for condition for V output is going to be 0. So if V output is equal to 0, if V output is going to be 0, then you will get 0 is equal to Rf by R into V reference minus V in. So it's going to be 0 is equal to V reference minus V in. So I can write it's going to be V in is equal to V reference. The condition which satisfies the above requirement, that is V output is going to be 0, is going to be option number A. Option number A is the right answer. So option A is the right answer. Okay. Okay, yeah. So these are all the memory based questions. These are all memory based questions. So after IIT Bombay releases their question paper, if there is any disturbancy, so we will discuss about the key and the question paper after that. Tomorrow I am going to discuss tomorrow from same time. So we'll be discussing EDG, electronic devices, GATE 2021. Tomorrow we'll discuss the questions of electronic devices, GATE 2021. Okay, get ready to listen to all the questions of electronic devices tomorrow. Okay, yeah, okay then. So we have something called plus subscription. So please do join for plus subscription. So the live, what are the benefits of plus subscription is you will be given live classes. You can attend all the crash courses. You can attend a weekly test. So these are for any given for any GATE aspirant. This weekly tests are very important to improve yourself. You can have doubt solving sessions. The sessions will be English and Hindi. So if your ranks are not good, if you want to increase or not bad, if you want to increase your rank, you can join the rank improvement batch. All these things will be benefit out of in plus subscription. So along with that, you have something called plus subscription. In the plus subscription, the extra benefits which you are going to get is you'll be given a personal coach and you will be given a study planner. You'll be having study booster sessions, and then a personalized test analysis will be conducted, and a preparatory study material which will be given as specialized notes, and practice sets will be available. Practice sets will be available for all you guys. And the fee structure for a plus subscription for 12 months it is going to be 27,225 rupees. For 18 months it is going to be 36,650 rupees. For 24 months it is going to be 39,600 rupees. This is all after application of 10%. After application of this code SVS10, which will give you 10%. Okay. Then for icon subscription for 12 months, it is going to be 45,224 rupees after applying a 10% SVS code 10%. For 24 months, it is going to be 66,600 rupees. This is also after SVS 10% discount. So as a time and again, I'm telling you, this 10% discount will be decreased to 5%. This 10% discount will be decreased to 5% after after a few days. So hurry up, sir, hurry up. So hurry up to get this 10% discount. So soon it is going to be decreased to 5%. So be careful. Join the classes as early as possible. Okay. So all my class notes are available. Will be available in the Telegram channel. The Telegram channel. That is Analog Gate English Telegram channel. So please download my class notes from Unacademy Gate English Telegram channel. And I am teaching right now on Unacademy Gate English channel. Please do subscribe for this channel. So where you can attend all the classes. This Unacademy Gate English will help you to prepare for the Gate 2022 and 2023 exclusively. So utilize this opportunity, my dear students, right? So another other channels which we have is going to be Creatix Gate EE ECE instrumentation, and then we have Unacademy Gate mechanical production engineering, and then engineering sciences. We have separate YouTube channel. For Unacademy Gate Civil and Chemical Engineers, we have separate channel. For Unacademy Computer Science and Information Technology, we have one channel. So Unacademy Gate questions, exclusive Gate questions will be available for Unacademy Gate questions. And then we have something called Electrical Junction, where you have electrical students. This is dedicated to electrical students, sir. This is dedicated to electrical students. Okay. So thank you for joining the class. So don't forget to like the session, share the session, and so one single like makes a lot of difference. One single like made a lot of difference. So please don't forget to like the session. Please like the session, share, and subscribe. If you are not subscribed, please subscribe and hit the bell icon. Hit the bell icon. Okay. Thank you. Tomorrow we'll be meeting on discussion of electronic devices, ED, electronic devices discussion at 7 p.m. as usual. Okay. Thank you. We'll catch up tomorrow.